Alright, so looking at the do now, we're going to start with finding the scale ratio between the figures below. So looking at this, in order to find the scale factor, we need to identify the original and the final, our input and our output. And we need to determine y over x. So looking at this, y over x is going to be 3/4 divided by 1/2. Because these are our corresponding sides that we can use. This one has nothing to do with it because it is not the corresponding side. 3/4 divided by 1/2 is equivalent to 3/4 times the reciprocal, which is 2/1. Doing some cross canceling, we end up with 3/2, which is equivalent to 1.5. Looking at the second one, use the grid, redraw the triangle with a scale factor of 0.5. So looking at this, we can see our original length is, if we count it out, 1, 2, 3, 4. And our original height is 1, 2, 3, 4, 5, 6. So using our scale factor, y is equal to 0.5 times x. That's going to give us a height of 3 equals 0.5 times 6. Give us a height of 3. So I'm going to draw really quickly height there. And the width, y equals 0.5 times 4. It's going to give me 2, so I need it to be 2 wide. There we go. And I am redrawn with a height of 3 and a base of 2. Scale factor of 0.5. Over here, it says, using the grid, redraw the triangle with a scale factor of 2.5. So this is actually the same figure. We have a base of 4 and a height of 6. So we can actually think about this as a T-chart if we want. Just a different strategy. Thinking about it kind of going into your test tomorrow with a height of 6 and 4. And our scale factor is 2, so y is equal to 2.5x. If we plug in 6, we should get 15. If we plug in x is 4, we should get 10. So I can't really see my grid lines here very well, so I think that is 10. And our height is 15. I didn't quite give myself enough space. I think this is 15. Alright, close enough. So this is our base of 10 and our height of 15. Alright, so that's just a quick reminder about how we do scale drawings. Hopefully we did a lot of that yesterday. Alright, let's go ahead and flip on over to our class book. So, writing our aim for today. Today's aim, Kipsters will be able to determine equivalent scale factors, for double scales. Alright, so we're going to look back at some of our work from yesterday, and we're going to use some of our scales to kind of think about what would happen if we scaled the drawing. So the situation we're given here is the school plans to publish your work of your dream classroom in the newsletter. Unfortunately, in order to fit your scale drawing in the magazine, they need it to be 1/4 of its current length. So yesterday, our actual class length, I believe, was 30, and our actual class width was 24. Our window and door lengths were both 3, and we had some other objects in there. I'm just going to throw in a desk, and our desk was 1.5. No, it was 2 by 3. 2 by 3. So our scale factor yesterday was a reduction of 1/3, 1/3, 1/3, 1/3, 1/3, and 1/3. So that gave us our scale drawing lengths. This one was 10, 8, 1, 1, 2/3, and 1. So we're being asked to take that scale drawing, so it's kind of like now I'm ignoring all of this over here and saying, hey, this is your original figure, but I need you to go ahead and scale that down by 1/4. So go ahead and use this table complete for me. Pausing the video really quickly, what would be the length in scale drawing 2 if we had to take scale drawing 1 and scale it down by a factor of 1/4? Alright, so go ahead and we multiply through our scale factor of 1/4. This one we're going to get 10/4, which simplifies to 2 1/2. This one we're going to get exactly 2. 1 times 1/4, we're going to get 1/4 of an inch, 1/4 of an inch, and 2/4 or 2/12 will simplify to 1/6 of an inch and 1/4 of an inch. So if we come down, scale 1 was 1/3. We use the equation y equals 1/3 x, and the scale factor for 2 was 1/4, and we use the equation y equals 1/4 x. Now, what is the scale ratio from the original to the second? So just looking at this, we started with 30. We ended with, we'll just put it as an improper fraction, 5/2. Started with 24, ended up with 2. Started with a window length of 3, ended up with 1/4. 3 was 1/4. And our desk length, we'll just have that one since it looks like we ran out of space down here, ended up with 1/6. So we want to figure out what the scale ratio was for all of these to make sure that it is the same. We're going to see if scaling something twice messes up the proportional relationship. I'm going to have, thinking about this is what we started with, our x and our y. 5/2 divided by 30, which is the same thing as 5/2 times 1/30. Doing some cross canceling, this is going to leave me with 6. 5 is going to be 1/12. So it looks like our scale ratio should have been 1/12. So let's make sure that that works for all of them. I have y over x is 2/24, which simplifies to 1/12. I have 1/4 divided by 3, which is, or 4. No, 1/4 divided by 3, sorry, lost my brain temporarily there. So that's 1/4 times 1/3. Gives me 1/12. Same here. And our last one, 1/6 divided by 2, which is the same as 1/6 times 1/2, which is 1/12. Alright, so what we can see there is that it does give us an equivalent scale ratio of 1/12. So we had a scale ratio of 1/3 and a scale ratio of 1/12. We could write a relationship from the actual, or the original, would be using that scale factor from beginning to end of 1/12 of x. So, coming up with a couple of examples here, we're just going to explore what it looks like when we double scale things to see if we can't find a relationship between what happens when we scale something twice. So, just a couple of examples. Let's do something like 30, where our first scale factor is 3, second scale factor is 2. Let's do something that's like 24, where the first scale factor is 2, and the second scale factor is 1/6. And let's see another one again. Actually, let's do something like 4, and a scale factor of 2, and then a scale factor of 3. So go ahead and pause the video right now and go ahead and find out what the value would be after the first scaling, and then what the values would be after the second scaling, and then calculate your y over your x from the original all the way to the second scale drawing to see what the total scale would be. So hopefully we're looking at this one, we would be thinking about this as y equals 1/3 times x. So we would have 1/3 times 30 would be 10, 2 times 24 would be 48, and a scale factor of 2, this one would be 8. So this one, kind of now ignoring this, it's kind of like, okay, this is y is equal to 2x on this first one, or 1/6 or 3 or whatever it is. So we have 2 times 10 would be 20. 1/6 times 48 would be 8. And 8 times 3 would be 24. So we want to calculate the total ratios between those. So we're now basically going from here to here. So our y over x equals 20 over 30 equals 2/3. And from our 24 all the way to our 8, so y over x is going to be 8 over 24, which simplifies to 1/3. And from a 4 to a 24, 24 over 4, which is equal to 6. So, looking at the relationship from the scale 1 to scale 2 to the total scale, is there a relationship between these things? From 1/3 to 2 to 2/3. From 2 to 1/6 to 1/3. From 2 to 3 to 6. Is there a common relationship between them? Think about that for a second, and go ahead and write down what relationship that you see between the scale ratios and the total scale ratio. Is there a way that we can calculate the total scale ratio without actually even knowing the values? So hopefully you've identified that we have 1/3 times 2 would give me 2/3, and 2 times 1/6 would give me 1/3 simplified, and 2 times 3 would give me 6. And we can see the same thing over here with our first one. 1/3 times 1/4 would give me the scale ratio that we found was 1/12. So we can actually find the total scale ratio given two scales by multiplying the two scale ratios. Multiply the two scale ratios to get the total scale ratio. And to some extent, this should make sense to us because all we actually did when we went through this entire process was we multiplied our original times scale ratio 1 times scale ratio 2 to get our final. And so what we think about here is if we use kind of our order of operations here and throw in some parentheses using the associative property, we recognize that all we end up doing here is multiplying scale ratio 1 and scale ratio 2, and then we can multiply that by the original. So that's just another way to think about why this happens. Alright, so we've got a couple examples here just really quickly. It says we have an actual drawing that is enlarged by a factor of 2 and then reduced by a factor of 1/3. What is the overall scale factor of the original to the final scale drawing? So again, this just goes back to the super simple concept. If we have something that is scaled twice, we take scale factor 1, or scale ratio 1, which is 2. We multiply it by a scale factor of 3, or the second scale factor, and we're going to get 2/3. So we could write our equation y equals 2/3 x to go all the way from the original to the second scale drawing. If we have an actual drawing that is enlarged by a factor of 5 but then reduced by a factor of 5/8, what is the overall scale factor? So once again, same idea, 5 times 5/8, and that's going to give us 25/8. And so we could write our equation y equals 25/8 x to get from the original to the final. I'm going to have to give you a little bit more instructions since you're going to be working independently on the partner work time. So go ahead and flip over your partner work time. Let me give you a few more instructions before you get started. Alright, so here you're going to measure the lengths of this particular triangle. You're going to put them here in these three boxes. And since you're not going to be involved with the partner work time that everybody else is going through, you're not going to get two cards, and so I'm just going to go ahead and give you the scale factors that are on your two cards. The first scale factor will be 2/3. And the second scale factor will be 4. Alright, that's actually all the information that I really needed to give you to get you rolling. So go ahead and pause the video, complete the rest of the partner work time, and then you can put it back on to check. Okay, so it's what is the scale factor between the original drawing and the one you drew. You didn't actually draw it, but we have the scale factor. We could calculate it without having to actually find the values. It would be 2/3 times 4. and that's going to give me a scale factor of 8/3 from the original, which means it is still going to be an enlargement because it is greater than 1, despite the fact that it's first a reduction. Using that, we could write the equation y is equal to 8/3 x, and if I wanted to find the area ratio, so this is just kind of a little bit of review here, I would want to multiply my scale ratio, which was 8/3, times itself. And that would give me 64/9. Alright, coming over here, we're told that we have an actual drawing that's enlarged by a factor of 2, but then reduced by a factor of 1/3. And the question is, what is the overall scale factor here? So we have a scale factor of 2 times a scale factor of 1/3. That's going to give me 2/3. Write an equation to represent the relationship. Y is equal to 2/3 x. What is the area ratio for the original to the second scale drawing? So that's going to be 2/3 times 2/3, which is going to give me 4/9. Write an equation to represent the ratio of the areas. So if I want to deal with the areas, I need to use the area ratio. A2 is equal to 4/9 times the original area. The original figure had a side of 4 centimeters. What would be the length of the scale drawing? So this is looking at sides, so I'm going to use my side equation. Y is equal to 2/3 x. And the original figure, that's our input, that was our x. Y is equal to 2/3 times 4. It's going to give me y is equal to 8/3, or 2 2/3. The original figure has an area of 30 centimeters squared. What is the area of the second? So again, I'm going to plug in to my area equation here, which is 4/9 times 30, because we're plugging in for our original here. We're given the original. Doing some cross canceling, that's going to give me 40/3. Or that is equivalent to 13 1/3. If the scale drawing had a side of 0.5 inches, the second scale drawing, and it's a side, so where y equals 2/3 x and has a side of 0.5. So I'm going to go ahead and change this to a fraction when I plug this in, because this is also from the second scale drawing, so I'm plugging that in for y. And I'm changing it to a fraction because I'm going to end up dividing by a fraction. That's just going to make things easier. 1/2 divided by 2/3 is going to give us 1/2 times 3/2. It's going to give me a y is equal to 3/4 of an inch. And the second scale drawing has an area, so using our area equation, and it was from the second scale drawing, so this is coming all the way from our end point. 30 is equal to 4/9 times our original, so we're dividing by 4/9, which is going to be the same thing as multiplying by 9/4. Doing some simplification here. This is going to cross cancel 15 times 9/2. 15 times 9 is going to be 135/2. Alright, so that's it. go ahead and move on to your alone time work and finish that up, and then once you're done, go ahead and move on to some independent work on Khan.